Good day, ladies and gentlemen, and welcome to the Brantley Cyberseminar conference call. My name is James, and I will be your operator for today. At this time, all participants are in listen-only mode. We will conduct a question-and-answer session toward the end of this conference. If at any time during the call you require assistance, please press *0, and an operator will be happy to assist you. I would now like to turn the call over to Mr. John Duncan, Project Manager. Please proceed.
Thanks, James, and welcome everyone to today's cyber seminar given by Sue Brantley on CZEN design concepts for observatories. So just wanted to go through a brief overview of the Quasi Cyber Seminar layout here. You'll notice the participant list in the upper right and the chat box in the lower right-hand corner, so you can send a message or a question to all participants or select one of the participants, and it's kind of like whispering in the back of the room. If you have any feedback on today's cyber seminar, we're always eager to hear about it, and that can be addressed in an email to me at townmanager@quasi.org. And if you have any seminar ideas, you can email those to Dave Tarbotton at Utah State University, who is helping to organize these. And this presentation can be downloaded right now in PDF format from the Quasi website on the Cyber Seminar homepage. I just wanted to quickly plug the last two talks for this semester. On November 3rd, which is a week from today, Dave Goodrich from ARS is going to be giving a talk on lessons learned from the USDA ARS Walnut Gulch experimental watershed and how they're expanding that work into the upper San Pedro Basin. And then on December 1st, Dave Maidman from UT Austin and TI of the Quasi HIS grant is going to be giving a talk on version 1.0 of that system. But we're happy to have Sue with us here today. Dr. Brantley is director of the Earth Systems Institute, I believe it is, and has received all three of her degrees from Princeton University. She's here to talk about CZEN design concepts and how the CZEN folks view this. So, Sue, I'll turn it over to you at this point.
Thanks, Jonathan. And thank you for inviting me to give this talk. I think this talk has arisen out of conversations between Rick Hooper and Chris Perry and I in terms of future initiatives with respect to size of the critical zone. And then the recent RFP that National Science Foundation has published. We're all excited about this RFP for critical zone observatories. And as probably most of the participants understand, many folks around the country are talking about hydrologic observatories, critical zone observatories, etc. And so what I'm going to try to do in this talk is talk mainly about some of the ideas that the Critical Zone Exploration Network has been developing for observatories, and with acknowledgement that these are a vision put forward by a group of people from the community, and this may or may not be the vision that the National Science Foundation actually chooses to support. But it's a vision that has been put forth in a number of documents, and I'll try to explain that and talk about that. So just to move forward here, as you probably know, the critical zone is a term first used by actually at Rutgers University, and it was defined in the National Research Council report to be roughly the zone extending from the outer vegetation over up to the lower limit of groundwater. And that's not a very precise definition, but you can think about it as the zone that supports terrestrial life on Earth. And a big piece of this zone is soils, and that tends to be the focus of much of my own research, and so many of the examples I use in this talk will be towards zones. In terms of understanding the critical zone, we need to understand physical, biological, and chemical coupling in this zone and how it responds to four things: climatic, anthropogenic, tectonic, and then how to read those changes in the critical zone in the atmosphere, in the Earth's surface waters, and in the soil. And I think there are so many fundamental questions here to be answered that it's a very exciting endeavor. You could also call this the unknown zone, which is interesting given it's the surface of our planet, because you can think about what we don't know about the surface of our planet. For example, the critical zone, how deep is the critical zone? How deep is the regolith? How deep does life live on this planet? We don't know these answers. What are the structure and chemistry of the regolith? What lives in the regolith? Where is the water? What are the fluxes of the water through the critical zone? How does the critical zone form from bedrock? So bedrock regolith transition. How fast does it transform? And then what is the impact of change on the critical zone, especially given the very fast anthropogenic change that are occurring? And I think it's useful to step back and think about this change and what humans are doing to the Earth's surface, and think about the different spheres of the Earth. Everyone's familiar with this curve showing atmospheric CO2 versus time. And this is the actual measurements in Hawaii and then measurements back in geologic time. Everyone knows that the atmosphere is being perturbed. Well, maybe not everybody knows this, but I think it's a growing consensus that the CO2 is increasing in the atmosphere. And this is fairly well established and fairly well understood. Similarly, we're starting to see a transformation of the hydrosphere. This is Earth's oceans. This is depth and latitude. This is observed anthropogenic CO2 in the ocean, and you can see the colors here. So this is the CO2 that's dissolving in the oceans and changing the pH of the surface ocean. And so we're impacting the oceanic hydrosphere. We're also transforming the hydrosphere in terms of changes in runoff. And these are just two figures that are showing this. This is the relative change in runoff during the 20th century, computed as 100 times the difference in 71 to 98 runoff, and divided from 1900 to 1970, so scaled, so it's as a percent. So you can see that runoff is increasing or decreasing in different parts of the globe. And then this is just plotted in a different way, the number of ones with positive change minus the number with negative change. So we're seeing changes in runoff in the surface of the Earth as well. Humans are transforming the hydrosphere also chemically. This is data that was published in 2001. This is DOC in lakes and some streams in the UK. And they posited that they saw a slight increase in dissolved organic carbon coming from peatlands in the UK, and they posited on the basis of laboratory studies that these changes in DOC may be a result to climate change. So there seems to be possibilities of chemical change as well, but this has been debated in Nature with several papers. So humans are changing the atmosphere, changing the hydrosphere, also changing the biosphere, as you know. For example, humans have been a major cause of extinction for almost 1/4 of bird species on Earth. The wood thrush is still found, but has been decreasing in abundance. And then you all know the story recently of the ivory-billed woodpecker, which either is or is not extinct, depending on whether you believe some of those latest reports in Louisiana. Humans are also transforming the surface of the lithosphere. This is land use change from 1700 to 1990, so 1700 to 1990. Kind of just for the U.S., green is primary vegetation, yellow is crops, blue is pasture. This is total carbon, kilograms per meter squared, and then this is land use shown down here. And you can see the drastic changes that we've experienced just in the U.S. In terms of the surface of the Earth. And the surface of the Earth is also changing in terms of soil carbon. This is an exciting paper published in 2005 by Brantley et al. In Nature, where data that have been collected in the UK showed that the soil organic carbon had changed. And you can see it easiest here. This is the rate of change. I don't quite remember over how much time this was, let's say over a couple decades or a decade, but showing the rate of change of soil organic carbon binned and shown here as pixels on a map of the UK. There's very little data like this available, but indeed we are impacting the surface of the Earth in terms of the chemistry as well. What Hooper and Christopher Allen have been talking about is the fact that we really can't predict this kind of surface Earth change the way we can predict changes in the atmosphere and changes in ocean chemistry and that sort of thing. And we've taken to calling this kind of a prediction, which would be a prediction for surface Earth processes or properties or fluxes, as an Earthcast. just as we think of a forecast for weather, or maybe, forecasting for ocean conditions, it seems that Earth surface processes, scientists would like to be able to Earthcast and make forward predictions about the surface Earth. And given the fact that the surface Earth you wouldn't expect would change extremely rapidly, you would think we would be able to do this. In contrast, it's very difficult to make such Earthcasts, and I just sort of showed an example here. This is changes over time, plotted in the global carbon uptake on land, where this is plotted for different model calculations, and the land surface is either a source of carbon or a sink of carbon, depending on which model you believe. And you can see that our predictions are very different in terms of the magnitude of the actual prediction. If you look at global predictions for CO2 flux to the atmosphere forward in time, so this is CO2 uptake into the oceans, either with a climate feedback or without a climate feedback, you can see that we can pretty well, with many different models, predict the CO2 uptake into the oceans, so that how much CO2 would be going into the oceans forward in time, versus look at how hard it is for us to make this prediction for CO2 into the land, so the uptake of CO2 by the Earth's surface. These are all the different model predictions, and you can see the variability in this prediction, even sometimes predicting that it's not just a sink, but it could be an actual source. So why is it that we can do better with ocean CO2 interactions than we can with land CO2 interactions? So another way to say that, and make it a little bit more general, is to say, how can we quantitatively predict or Earthcast the response of the Earth's surface to natural and human perturbation? What do we need to do this? Well, we need techniques that can measure the controlling variables at the relevant scales of time and space. We need comprehensive long-term and systematic observations of the key variables. We need to measure certain thermodynamic and kinetic data that can actually help us predict the fluxes of matter and energy at interfaces. We need conceptual models for many of these processes. We need governing equations to take these conceptual models and make them predictive. And then we need to be able to model the dynamical complexities and the emergent phenomena that occur because so many of these processes are coupled. So given our growing ability to forecast weather and climate, why can't we Earthcast the associated changes in the critical zone? And probably you're already out there thinking the answer already. But in a nutshell, the way Rick Hooper and Chris Perella and I have phrased this is just to emphasize the slow mixing rates of the surface Earth, which allows extreme heterogeneities to develop and persist over space and time. And these heterogeneities are in physical forces, they're in chemistry, they're in biology. So because of this heterogeneity, largely because of this large heterogeneity, which is often characterized and which we don't know how to model, we cannot Earthcast the rock plus rivers plus sediment plus water plus air plus biota system. And we're much more successful in modeling the homogeneous fluids in the atmosphere of the ocean than we are for the surface Earth. And it is precisely this problem or this difficulty that many of us are so excited about this area because there are so many questions that are ripe for research right now. There's also a human resources challenge. The critical zone, this sort of critical zone science crosses disciplines, all the way from biology to geology, crossing chemistry, crossing physics, hydrology, engineering, and it also crosses scale. So it goes all the way from a landscape scale, which isn't even shown here, to a soil profile scale, right down to the nanometer and the molecular scale shown here by this image by John Chorler. So the crossing of scales and crossing of disciplines makes a human resources issue in that most people are not trained to be able to work across disciplines, nor are they trained to work across scales. And so I think many approaches have failed, and we are now, I think, really around the world starting to recognize that these problems are not a hydrologic problem, they're not a cellular problem, they're not a biological problem, but a problem that covers all these different processes. And so we need an approach that can incorporate these kinds of processes. Well, scientists around the country and indeed around the world are working across these disciplines, and yet many of us have articulated that these very important fundamental questions that lie right in this area of critical zone science often fall in the cracks, if you will, between the funding paradigms for the different agencies. And I've just shown some of the agencies that do some excellent research or fund some excellent research in this area. But as I hope many of you would agree, there's a lot of research and fundamental research that could be happening that isn't happening, partly because of this problem in the schematic, shown here in this schematic. Well, as an outgrowth of this kind of thinking, in 2003, a group of us formed what we call the Weathering System Science Consortium, and we wanted to promote collaboration among all types of scientists studying rock-water interactions at the Earth's surface. And this group is now comprised of scientists from more than 50 universities here and abroad. And it has grown to generate a vision for what we call the Critical Zone Exploration Network, and that was articulated in 2005. We've kind of changed our name from Weathering System Science Consortium to the Critical Zone Exploration Network, largely in recognition that this word, which to me as an earth scientist really means all the physical, chemical, biological processes occurring within, back at, or near the Earth's surface, this word tends to make biologists think that they're left out, or it just doesn't sound as all-inclusive. And so that's what led us to calling this kind of initiative the Critical Zone Exploration Network, and starting to talk instead of about weathering system science, but talk about critical zone science. Let's just give you a little bit of history. I don't really want to talk about this very much, but we started and had a number of workshops and open meetings. And it culminated in a meeting that Don Sparks and I were in last year at the University of Delaware called the Frontiers of the Critical Zone meeting. That was the meeting where much of this was articulated in a report, and I'll show something from that report in a little bit. We have also, in that work, have articulated 4 questions that we think encapsulate the driving questions for critical zone science. It's just a way of thinking about what we're trying to do here when we think about earth casting. So, the first question is really related to the interactions between the critical zone and the atmosphere. What processes control fluxes of carbon, particulates, and reactive gases over different time scales? So we're really thinking about this branch of this particular diagram. Second question, how do biogeochemical processes govern long-term sustainability of water and soil resources? So we're thinking about sustainability issues. We're thinking about the fact that the food is governed by sustainable soil, and the water we drink is governed by sustainable water. And so all of these interactions here. Third question, how do processes that nourish ecosystems change over human and geologic timescales? So we're thinking about the fact that nutrients are derived from the critical zone, and we're thinking about all those types of processes between biota and regolith. And really, when you think about it, it is this regolith that creates the surface area that provides the nutrients that come from the rocks that support plant life and ultimately much of the terrestrial life on Earth. And then finally, questions about sculpting of our surface Earth, and thinking about how variations and perturbations to chemical and physical weathering impact the critical zone, and thinking about questions about coupling between chemical and physical weathering. And just to drive home these 4 questions, I have 4 slides in a row here that just give you little tiny snapshots about this. And we work from interactions with the atmosphere to questions of sustainability to questions about nourishing ecosystems, and then questions of sculpting landscape in these little vignettes. First, this is a slide from Jonathan Leake in the UK, published in 2001, thinking about questions of our atmospheric carbon and storage in soils. He's done some beautiful studies of plant growth, and then using radionuclides and being able to image storage of carbon. And these hot spots show, after a certain amount of time, the storage of carbon at the root tips when this plant was exposed to radiogenic carbon. Second, a sustainability question. This is a slide from Janet Herring showing arsenic in micrograms per liter. Many people around the world are working on the problem of arsenic in drinking water, and just an extreme example of some of the effects of having this arsenic in drinking water. This is truly a rock water interaction problem of great importance because the arsenic is coming out of the rocks and getting into drinking water and impacting human health at a huge scale. Another sustainability kind of issue, this is a slide from Don Sparks, just emphasizing that many of these questions related to the chemistry of water and soil can only be investigated at the synchrotron scale or the nanometer scale. So these are some images from SXRF or XRF documenting soil chemistry, showing the presence of zinc and using these techniques to be able to actually pinpoint at a nanometer scale where certain contaminants are in a soil. Just an image from a recent cover of Science, thinking about how erosion is tied in with biota and thinking of extreme impacts of physical processes such as erosion on biota. And a really nice quote by Young in this same issue, they called soils the most complicated biomaterials on the planet, and I think that's very true and shown in this particular image. And then finally, just an emphasis about the extreme change that we are reaching on the surface of the Earth in terms of erosion. This is just a figure and a little statistic showing that in the 1980s alone, the world lost topsoil equivalent to half of the topsoil on U.S. cropland. And I think recent papers by Bruce Wilkinson and a new book coming out by Dave Montgomery in Berkeley really emphasizing the huge impact on erosion that humans are having. Okay, well, to answer those kinds of questions, the group that I've been working with, RISC and CZEN, to be able to articulate that we really need what we're calling a critical zone exploration network that all such critical zone scientists can use. And this would be open for investigation using all chemical, physical, hydrological, you name it, techniques. And I want to talk to you about what that vision incorporates. First, we envision this as a network of people. We envision it, obviously, everyone from students to faculty and researchers that would be drawn together through conferences, through, for example, NSF-funded scholarships or fellowships, cooperation among funding agencies, since many agencies are interested in this area, and then a network of people that are drawn together by education and outreach goals. We see that a network of ideas, the coupling between chemistry, physics, and biology over time really makes it necessary that we need new ideas, new conceptual models in order to make these earthcasts as I've described them. A network of data. There's a small amount of funding that's been given to Penn State and Duke by NSF to create a cyber infrastructure for the CZEN concept, and that's been spearheaded by Doug Miller and Mike Hoffnagel and also Dan Richter. And I just put some email addresses here because for those of you that are looking on CZO proposals, we'd be really happy to see if our cyber infrastructure that's being developed by Doug Miller and Dan Richter could actually help in terms of our proposals, so that we would work with people where our cyber infrastructure might be helpful. And we're working with the project folks on this as well, and there's a lot of interaction going on there. CZEN would obviously need to be a network of tools, and there's many new tools that are emerging that are making this kind of research possible. Cosmogenic isotopes is one of the very foremost in terms of dating of exposure surfaces. The information that's coming out about how fast surfaces change is really exciting. Work of people like Darrell Granger, Paul Bierman, other people around the world that are really showing us how fast these processes can happen. Other new isotopes and tracers that are being used to document biological cycling, uranium disequilibrium that is allowing people to make models of combination of grains and trace rates close to equilibrium, imaging tools in soil observatories, new molecular biological techniques. There's just many of these that are now being applied to environmental systems and are creating a lot of excitement. Nanoscale spectroscopy, we've already mentioned. New environmental sensors. NSF has a big effort to fund environmental sensors that can allow us to get real-time data. And these have been available now for quite a while in terms of gas sensing and water sensing, but there's starting to be sensors also available for chemistry and for molecular biological measurements, and those are exciting. And then there's a lot of development of 3D reactive transport and hydrologic models, which are allowing us to actually synthesize data in ways that we couldn't before. Perhaps most importantly, or most germane for this conversation, CZEN has also been articulated as a network of sites. And we saw the need for a network because a network can allow us to unravel and quantify the effects of external forcing factors on the critical zone formation. Networks also needed in order to investigate emergent physical, chemical, and biological processes. And so this network has been imagined, visioned as a network of sites funded for approximately 5-year increments, perhaps building on other networks such as the RTER or NEON or other networks that you might think of. And it's envisioned as a way to bring the critical zone community together to answer fundamental questions involving the interface of Earth materials and life, and allow very sort of pinpointed questions to be answered in ways that we would have fundamental answers that could then be extrapolated to other sites. So we envision this network of sites to allow generalizable fundamental knowledge to be developed. The sites were envisioned to be distributed over a range of environmental variables to be proposed by the community, to be investigated in ways that certain standard data sets would be collected for each site. And we also recognized that some sites would be more instrumented than others, and some sites would be more equal than others, and would be instrumented for longer periods of time. This is our favorite diagram that shows the vision that we've been articulating and that we've been talking about to several agencies, including USDA, DOE, National Science Foundation. And each of these boxes is a schematic for a site. And what we think is important is to pick sites that can actually ask questions about how certain processes vary as a function of some environmental gradient. So, for example, a lithology gradient, or to look at how a particular process varies across a topography gradient or climate biology. These are just some of the gradients you might envision, but other gradients could also be envisioned. Geomorphologists typically tell me that we should relabel this as uplift, and I think that obviously that would make a really interesting gradient to study and to investigate. Like, what is the effect of uplift on weathering, for example, or uplift on uptake of soil organic carbon? And so, in our minds, it's the network itself that we need. It's the siting of these sites across environmental gradients that will allow us to answer important questions. The legs of the network obviously could test their forming factors. These are just the famous factors of RENI and kind of written out a little bit more specifically. But as I've already mentioned, we don't have to be limited to these variables. And for example, disturbance was on my last slide. And I've already mentioned uplift, and I'm sure you can think of others that could be listed as well. We saw a little bit about what the criteria for sites should be. These are sort of some minimum criteria. We think there should be unique scientific merit. Sites should really be chosen to test a very important hypotheses. So to test or answer questions like the fundamental questions that I articulated earlier in this talk. I think clearly the site should be physically accessible. We have emphasized over and over again that to solve the kind of people that are interested in the critical zone, we have to get more than one kind of person together. We need to get different disciplines together. And so we need to have sites that are logistically accessible where people can work together. The weather list has to be something that can be characterized. The party list should be characterizable. The surface water, the groundwater should be measurable, sampled. And the biota should be something that could be characterized as well. And I think I've more or less said this when I was talking about other points up here, but the network sites should be useful for a whole range of people in terms of a range of interdisciplinary questions. Here are some site attributes to be considered in site selection, just written out. This is a report from the University of Delaware meeting. That can be downloaded from the website, and I'll show you that in a little bit. But you can think about some of these variables and how choosing sites and choosing an environmental gradient that maybe isolates many of these variables but varies one of the variables could allow you to test very important questions. Now, when you look at this diagram, we highlighted some of these in green, and that was because when you think about it, some of these sites might lie sort of at the nexus of several of these gradients. And so these sites, we have always thought, might possibly be worthy of more instrumentation or longer time frames of investigation. And the intersections of these gradients might be considered critical zone observatories. These are the sites open over longer terms to all of the different disciplines. And I've always imagined that these sites might be sites that, if you think in terms of a kilogram analogy, could establish the standard temperature and pressure, or STP, of critical zone science. So let me just explain what I mean by that. As a geochemist, chemical analyses are always compared back to the standard temperature and pressure, STP, so 1 atmosphere and 25 degrees. That's chosen just because we always need a reference state or a standard state. And so I have always thought of the intersections of these gradients, these green boxes, as being sites where we could do a lion's share of work and kind of get some observations that would be more or less the STP, if you will, and then we would compare other sites to those. And so I think that as this critical zone exploration network idea, gets exemplified, it's possible that the very first critical zone observatories, at least to my mind, or to the group that I was working with, these very first observatories, it would be best if they were chosen so that they could be these reference sites or these STP sites that form really the basis for comparisons as shown schematically.
Sue, can I just jump in and ask you to hit that Synchronize My Display button? It's just to the left of your laser pointer. That's just, that was the big screen. So you can probably click that again. And then it's just to the left of the laser pointer. It's 3 down from the large display.
Okay.
Thanks. Hopefully that'll work. I appreciate it.
Okay. Gosh, there is somebody out there. I thought I was just talking to my computer.
We're all here. Just muted.
Okay. So here is just a schematic of what we have envisioned these critical zone observatories might look like. We have seen them as nested with instrumented soil sites. These instrumented soil sites would have lysimeters, tensiometers, piezometers, all sorts of sampling would be going on to get solid chemistry, mineralogy, microbiota, water chemistry. But these would be cited within a catchment, which would be instrumented so that the hydrology and the water chemistry would be measurable as well. Here's examples of the kinds of proposed activities that have been discussed in instruments for sites in CZEN, and this is not a particularly great slide because this writing is so small, but you can see all the different kinds of instruments that have been discussed or measurements that have been discussed. And, as the fundamental questions that are being addressed are articulated, clearly choices would be made here. That particular table is published in the workshop of our report from the University of Delaware meeting. And this just shows you this picture. It can be downloaded at the website, which has recently changed. We are now calling the website www.czen.org. And this has been developed by Mike Hofnackle and Doug Miller, both at Penn State and Dan Richter. Well, CZEN is actually starting to exist. It's a vision that it's also starting to exist. We were able to get a little bit of money from NSF to fund some seed sites, and we chose 8 sites based on proposals made at the University of Delaware meeting. And we're very excited about this current CZO competition. And as I've said before, although this CZEN idea has been articulated by our community, it's not being it's not an NSF-sponsored idea. This is coming from the community, and so we don't really know what the result of the CZO competition will be. But we're extremely hopeful that the critical zone observatories that are chosen as part of this RFP would actually move us forward in this vision that we're articulating for the network. People have already started. We have created some community with CZEN.org and the listserv that was previous to this. And obviously, Quasi doing the same thing with a slightly more hydrological community. Ideas of the interactions that have been fostered by Quasi, by our group, by UNSED, by other initiatives, you can really see the interest in this particular area and how it's moving forward. As I've already mentioned, Doug Miller, Dan Richter are creating a cyber infrastructure. You can see it at CZEN.org as it is just getting off the ground now. And then Quasi also has a cyber infrastructure that's ahead of ours. But our group is talking to the Quasi folks, and as it's emerging, it looks like Quasi's cyber infrastructure will be providing access to data for streamwater, and our cyber infrastructure will be providing access to the chemical and neurological data of soils right down to bedrock. And two is the modeling efforts that the Center for Environmental Kinetics Analysis is pursuing here at Penn State, and then the efforts of the CSDMS group, which is the Community Surface Dynamics Modeling System, which is just funded to help get modeling efforts for the critical zone and for the surface Earth moving forward. So the CZEN is starting to exist. We have international partners that are talking to us about this effort and are using the critical zone terminology and the critical zone exploration network vision to actually get funding in their own communities, in their own countries. And there are already competitions that are being announced in other countries, and there's already been funding awarded based on a vision that was really started here in the U.S. For this critical zone. And as I said a little bit earlier, we are really hoping that this current CZO competition could be a start for what we have articulated as CZEN. As I said, originally the CZEN vision suggested that all sites would be created equally, and that each of these sites would be instrumented for short amounts of time. But as the idea has evolved, some of these sites would need to be instrumented for longer periods of time and instrumented more heavily. And so these could conceivably be the critical zone observatories that the NSF is going to choose in the next several months. Okay, if our vision were to be implemented, then these first CZO sites would be chosen because they would provide good sites for more sites that could be investigated along environmental gradients. That's what I've tried to articulate here. They should provide baselines, and it would make the most sense, according to the way we look at it at least, if these two sites were somehow chosen at least partially because they can provide appropriate comparisons one to the other, and that they will also be able to provide a baseline for future studies. So I hope I've made that clear. It's a little bit tricky because, as I've said, ultimately the choice of these sites is going to be due to the panel and to the review process. But what we're trying to articulate is what this community could really put into place that I think ultimately would have really moved us forward. We are hoping that the proposers for CZOs will actually contact each other and actually think about what they're proposing in the context of each other's sites. This is actually kind of a revolutionary idea. Normally when you're proposing an idea or an NSF, you keep your cards close to your chest and you don't talk about your site, you don't talk about what you're trying to do for fear that somebody else might outflank you. But we're very much hoping that people see the importance of how building this network could actually move us forward, and how if we could pick two sites, or if NSF could pick two sites that are sites that, for example, maybe are in the same climate regime but are in different lithologies, or maybe are in the same lithology but are in two climates, or, and I'm going to try to think like a geomorphologist, and I probably won't do so well because I'm not a geomorphologist, but maybe two sites, one of which is experiencing very fast uplift, and one of which was experiencing very slow uplift, but everything else is lithologically the same, or the climate is the same. What would make the most sense in a long-term development of the network is if these first two sites could actually more or less resonate off of each other. And this is a hard thing to do because the competition for these two sites is going to be based on reviews and panels and not necessarily on a proposed network idea. But I think that the PIs themselves can actually discuss among each other, and proposals could come in articulating that the proposed site is an excellent site for such and such a reason, X, Y, and Z, and then could actually talk about some of the other proposed sites and could make the argument to NSF why these other sites were, how they could be paired with the proposed site to make a good one. Anyway, that's an idea, and we're hoping that conversations will ensue. So I think this is the end of my talk. I went a little bit faster than I expected. What I was trying to articulate here is that to answer the kinds of questions we're trying to answer, in order to be able to earthcast, the way atmospheric scientists can weather forecast, or the way that ocean scientists can forecast, we think we need a coordinated worldwide effort, and we have been articulating that as CZEN, the Critical Zone Exploration Network. This sort of research will need to investigate reservoirs, processes, fluxes, and timescales, the timescales of response to change. And only with this kind of research where we can actually test important questions across environmental gradients at sites that are carefully chosen to answer fundamental questions, only with this kind of an approach will we be able to move forward quickly in terms of this very hard goal of earthcasting. So it is a process that incorporates many disciplines and across many different scales, and I think that this Critical Zone Observatory RFP that's out, that NSF has put out, is extremely exciting in terms of seeing what will emerge and what kind of sites could actually establish perhaps the first sites of such a network and move us forward in this area. So I think that's all I have. Thank you very much. I hope that you'll visit our website if you're interested in the cyber infrastructure, and then I can take any questions if somebody has a question.
Well, thanks a lot, Sue. I really appreciate it. It was a very nice talk. And so, James, I guess we'll open it up to questions at this point.
Ladies and gentlemen, if you wish to ask a question, please press star 1 on your touch-tone telephone. If you wish to withdraw your question or your question has been answered, press star 2. Questions will be taken in the order received. Our first question comes from the line of Richard Hooper. Please proceed.
Hi, Sue. Thanks. It was a great talk. I just wanted to sort of, emphasize or maybe reinforce your comment on, and maybe elaborate a bit on, we know that, nobody knows what's going to be selected by the panel and by NSF, and this is this causes some angst, and we all understand that. But I think what's important for all of us on the phone, for the community to realize, is that this is a real test by NSF to see whether what we've been asking for over the last years from the critical zone community, the quasi-community, the ecologists, et cetera, for these larger scale field studies and longer term field studies, whether it really will result in innovative science. And I think whoever is successful, whatever teams are successful in proposing these observatories, it's really going to be important for the community as a whole to try to take advantage of that and use them, and to figure out how we can truly get these community facilities to work. None of us have ever done this before. Probably the LTERs have the most experience with it, but it's a brave new world, and trying to figure out how to do our science and how to take advantage of these sites as well. So the concerns are duly noted in terms of how these sites will be chosen and in what sense they'll be optimal. But whatever we have to start with, I think it's important that we all somehow try to use them. and demonstrate their utility.
Yeah, I think that one really positive thing that's been emerging is that Quasi, Rick Cooper and I have been talking quite a bit, and I really think that what has been emerging from the community are very complementary cyber infrastructures and complementary visions, and I think that this has also been involving Chris Taylor, FMN said, and I think that NSF has been listening to the communities, and I think this Critical Zone Observatory RFP is responding to the communities at the same time that what kind of sites are actually chosen is really going to be up to NSF and up to the panels that are put together in January or whenever the selection is made.
Right, exactly. No, and I think your vision that you laid out here is a very compelling one, and one in which I think we all can get behind and can contribute to. So, and it's really, I think, evidence of more people coming together, working will also support the concept and will reinforce the need to NSF for why these critical zone observatories are important and should be continued. So, that's all. Thanks.
Mm-hmm.
As a reminder, ladies and gentlemen, to ask a question, please press *1.
Or you can also type it in your chat box.
Do we have any PRs out there that want to talk about what they're proposing? Or is everybody too shy?
We do have a question from the line of Larry McKay. Please proceed.
Yes, Sue. I enjoyed your talk. We're very interested in this, but we've been struggling, as I'm sure many people have, who are not PIs, in terms of trying to define how we can participate effectively in the current call for proposals. And it's really not clear what sort of the best way to address this is. I was wondering if you could make some comments on that.
So the question is, for somebody that's not PIing a proposal and hasn't already gotten onto a team, how you might get involved with someone else's team. That's essentially what you're asking.
Yes.
Yeah, I know that's a great question. And I think, you know how academics are. Everybody's kind of running around trying to get their house in order. And I know firsthand about a couple of proposals that are going out, and that's exactly what's happening. Emails are flying around. I would suggest that you might consider posting a message on the CZEN.org website, or I don't know as much about how Quasi operates, but the Quasi website, asking for, stating what it is that you might be interested in working on, and asking if there's any interest from any of the teams to have you be involved. I know that one of the questions that we had when we saw the RFP from NSF was, well, could we propose multiple catchments instead of just one catchment? And originally with CZEN vision, we would have liked to have been able to have multiple sites because really, we think the comparison across sites, across the environmental gradient is really where the answers are going to come from. But the RFP really makes it sound like probably one watershed is what's going to win the day, although who knows, because I don't think that multiple watersheds is necessarily ruled out. But anyway, my point is that I think multiple watersheds might have been able to bring in more people, and if there really is only two watersheds that end up being chosen as critical zone observatories, then it may be harder to get as many people involved. That's just an observation. But if you want to write me or put an email on the CZEN.org website, I know that people are interested in finding who's interested in the community to become involved. Maybe Rick Cooper could say something about the Quasi side of it.
James, do you want to pass Rick through? Or just take a second?
Okay.
So he can't talk unless we patch him in or something?
Apparently not.
James, are you there?
Richard Hooper, your line is open.
Okay, thanks. Yes, let me just add another thing to Larry's question. I think that the intent is certainly, Larry, that even after the site is chosen, that these sites have a positive obligation to host additional researchers. And so the notion would be, too, that as you write proposals, you should be able to write proposals to do work at the site. So we're trying to have an open system that these are community resources. It's always been the vision. There's a discussion at Quasi on this. Beyond that, I would say it's a matter of, yeah, as Sue said, either posting something on her site. We actually do not have we don't have a collaboratory up in that sense. They were just discussing about designing one to support this. But I guess I just would emphasize that this is not just who gets the proposal, or whoever gets the site, is the winner and everybody else are losers. It's rather that these sites are supposed to be community sites. Now you can't, the resources are limited. The PIs cannot, support your research, but they should be, they have an obligation to be open to host your research if you're coming with your own funding to do work at the site. So that's definitely a part of these sites.
Yeah, I know the two proposals that I'm involved in, we've discussed, what mechanisms that we could have to invite new researchers in. So, some of that remains to be seen how that plays out. But I think that probably most of the people around the country are thinking along those lines. Larry, I just looked at your website. So why don't you email me, because I have a couple ideas.
Great. Any other questions?
We do have a question from the line of Mike Ellis. Please proceed.
Hey, Sue, can you hear me?
Yes, I can. Nice to talk to you, Mike.
And you too, and everybody.
Did I state the NSF start all right? I was trying real hard.
I know you were. I don't have a question, but maybe I have a comment, which does speak to that. Very good talk, by the way, and of course and everybody knows, I think, that we are listening and trying to respond as best as we can.
I really appreciate that, that's for sure.
That's good. But I would be a little bit cautious in one thing, that I wouldn't want the audience to get the idea. I don't think you mean this either.
Mm-hmm.
But what's written in the CZEN white paper, or the sort of the CZEN sort of mission and vision and so on, is entirely what's driving the CZO solicitation. But there are, of course, other components to come into it. So I just want to make sure that people don't go sort of running to the CZEN document and use that to purely guide the proposal construction. But they do need to read the solicitation carefully and to read the letter of response that we sent out to folks.
Yeah, absolutely. And I was trying to say that, but it's hard to make that clear. I mean, people keep asking me questions related to that, but our document is a vision put together by a community of people, and there are, beautiful documents and vision that's come out of Quasi and come out of Unsaid and, Sal and a lot of other folks. And, I'm speaking about, what I know about and what I've been working on. And I know that NSF has been responding to that to some extent, but NSF is responding to the entire community, not just this particular community.
Yeah, that's right. And if you can't field some of these sort of inquiries that you're getting apparently, then by all means ship them to us, and we'll do the best we can. But you should know too that we are very, very excited about this, and we're really hoping for some great stuff to come out of it. Because of course, if it's a success, then it will grow into something bigger.
But can we depend on that, Mike?
Well, as much as you can depend. No, I would not say that.
Do you know what the time scale will be? Do you know when the panel will meet or anything like that?
Well, it will meet very shortly after the, it will meet, I think it's in April or something like that, but it will meet in time to get results out to people so they can start doing something in the summer of 2007. That's always been our intent. But we haven't got that far yet,
right.
Picking a date. So you can imagine that lots of, since everybody knows who's submitting the proposals, which wasn't supposed to happen, actually.
Yeah, but we're clever, Mike. We figured it out.
Yeah. Anyway, where was I going with that? There are lots and lots of conflicts of interest, so it's going to be tricky to put this review process together. But it'll be good, and it'll be fair, and it'll be careful, and it will be very attentive, too.
Yeah, and I was pleased to see, you know, on the names of people that were submitting the letters of intent. I'd say most of those names I don't recognize, many of them, half of them, and I think that's great, too. I mean, so there really is a solicitation that's talking to a really large community.
Yes.
And shouldn't be confused with just a community or just the vision that I've been talking about.
Okay, I guess that's my comment, so I'll let someone else talk.
Thanks, Mike.
Yeah.
Any other questions out there?
There are no further questions at this time.
Okay. And it is the top of the hour, so I guess this is last call for questions. But Sue, thanks again for a wonderful talk.
Thank you. It's fun to talk to my computer.
Okay, I guess without any other further questions, we'll see some of you back next Friday for Dave Goodrich's talk. But thanks again, Sue. I appreciate it. And thanks,
Thank you
everyone.
very much. Okay.
Take care, everyone.